In this lesson, we're going to learn how we can make our particles grow, as well as how to use an execute node to combine multiple execute ports. So here's where we left off, and you can see that our particles are turning black in the viewport. However, our strands are still covering them up. So we need to increase the size of our particles while they're in the second beaker. So let's add in a node to do what we want, and again we'll use the test distance to surface to make sure that we're inside the second beaker. And let me just right click and hide these values so they don't appear anymore, because we don't really need them. We know that this is working. So we're trying to change the particle size so we can test it, we can get it, we can modify it, or we can set it. Now, similar to before, I prefer using the set nodes. The modify nodes do have a lot of interesting ways to modify and change these properties. However, the set allows us to easily control it. So let's drag in a set particle size. So the first thing we can do is double click, and let's set it to 1. Okay? And now we need to, of course, plug it into our if, the exact same way we have our set particle color. However, if we plug it into the same port, you'll notice that these two overwrite each other. And so we need to figure out a way to combine or to plug multiple executes into a single port. Now, to do that, we can use the tool inside the execution called execute. And all this execute tool will do is combine multiple execution ports so that we can chain them together. So you'll notice I just dropped it on, and we can connect the set particle size execute to port 1, and then the execute into the if true, and then we can add the set particle color into the new port. And now both of these will be plugged in and moving through this if node. So the execute does not actually change any data. It just allows us to plug multiple things into a single port. And actually, I really enjoy using this to make my ice tree a little cleaner. So normally I would not have so many ice tree connections. I'd plug all these through a few execute nodes so I could clean up my scene a little. For example, these two bounce off surfaces, this is a perfect candidate to drop in an execute node, plug them in, and then use only a single port of your ice tree instead of multiple. Now, of course, this is not actually going to change our simulation. It is only for ease of use. Now, I'm sure you can imagine that ice trees can get rather large. So another thing I'm fond of is creating a new execute port, plugging it into the ice tree, and now, if we need to start adding new nodes, we almost have a mini ice tree if we have an execute node. So it's a very useful node that can help you organize, and it's essential for when we have to do things like use multiple executes through a single condition node. So now if we play this back, we should see that as soon as it enters the second beaker, it gets much larger and gets set to a size of 1. Of course, we can increase this to figure out how large we want these particles. We might want something about 1.34. Now again, we're getting a very sharp change as soon as it enters the beaker. So let's figure out how we can do something similar to our get particle, subtract, and set with our particle size. So the first thing we need to do is get the particle size. Scroll down, grab a get particle size node, and so to this we're going to add. So all we need to do is type add, and we can find it under our basic math right here. So let's add to the particle size and then plug the result into our set particle tool. So again, the add node is very simple. It just takes value 1 plus value 2 and sends out whatever that number is. So let's double click this, and let's add a very small value such as 0.05. And let's hit play. What we should see is that instead of just immediately changing into a new size, our particles begin to get larger and larger the longer they're inside of our beaker. However, as you can see, they keep getting larger and larger and larger, and they don't stop. So this is going to be a problem because we obviously don't want this result. So we can do something called clamping it, or in other words, we can set a maximum for this add value. So again, this is going to be found under our math tools, or you could just type clamp, but we can find it under math and basic. So clamp will essentially take our value, so let's plug the value or our add result into the clamp value, and then we have two limits. So we can say a lower limit and an upper limit. So for our upper limit, let's type in 1.3 or 1.4, depending on how large we want this particle. And now let's plug the result into size, and if we play this back again, we should see that our particles are growing, but they only grow to be so large. So we don't get that exact same runaway growth that we had happening earlier. As we can see, these particles are now staying inside of our beaker and being a little bit more controlled. Okay, great. So I'm going to hit Q and take a look. We can see that we still have a little bit of the strands, but we also have the much larger black particles now darkening the entire scene. Could, of course, increase this clamp to something like 1.6. Now, at this point, the particles might start interpenetrating or going outside of this beaker. So we might want to come in here and go up to our bounce off surface and increase the offset distance a little bit because we are scaling these particles up. So by increasing the offset distance to something like 1, we should be able to see that these particles are growing larger, but they do stay inside of our beaker here. So I'm just going to let a few more of these particles get into this beaker, and then I'll hit pause, and let's take a look. Okay, this is looking much more to what I was trying to get. A very dark mass, and on the left, these bright things fly out, and then they congeal into this darker colored particle. Okay, so let's finish this off by doing one more thing. I don't really want to render out a 2000 frame sequence. I only need about 250 frames for my render, so let's type in 250 to just give us a cutoff point for our simulation. And we can either cancel or let it simulate through. Just hit play and see the simulation. Now, currently, we start with no particles in our scene. And this will, of course, mean that the particles look like they're appearing out of thin air. So in the next lesson, we'll take a look at the various rendering settings we have available inside of Softimage, how we can render out an image sequence, and a quick tip for getting around this problem of the suddenly appearing particles.